Thanks for joining my session. I'm really excited to talk here. This is my first time joining RailsConf, as well as this is first time I'm giving a presentation outside of Japan. It's titled Troubleshoot Your Ruby on Rails Microservices with Distributed Tracing. My name is Yoshinori. These are my Twitter IDs. Please follow. And if you read Japanese, please follow the second one. I'm more active on that than the first one. And you can reach me out on any of those accounts if you have any questions. Feel free to ask any question after the talk. Oops. I work at a company named Untitled from Tokyo. For those who don't know, Untitled provides web services and mobile apps that helps people meet and exciting companies visit future teammates who share the values and who share the values and uncover jobs people are passionate about. Now, let me start with a poll. Please raise your hand if you work on a microservice architecture. Please raise your hand. 30%, I guess. Okay, thank you. And I assume you are suffering from debugging them or fixing them whenever a problem happens. So this talk is for you. And how many of you are working on the monolithic Rails app? Please raise your hand. Yes. Okay, cool. Thank you. So those who work on the monolith app, you are lucky. You must be productive enough on your code base. And this is a huge, gigantic, 10 years old Rails app. But if your product is successful, your system and your engineering team grows really, really quickly. So whether you like it or not, your system tends to become a distributed system. So this talk is also for you as well. And I was showing this before. Would you please vote on the poll? I made this in Twitter this morning. And I'll see the final result at the end of the presentation. I think only 10 minutes left to vote. I'm on at LUBTCHNO. Yeah, I'll take a pause for 5 seconds so you can search it and vote it. Okay, good. In this talk, I will explain why you need distributed tracing, what it is, and how it helps in microservice architecture. And in the second part of the talk, I will introduce Open Census, which is a set of libraries for distributed tracing and other observability features. And I will show you how you can use Open Census in your Rails applications. Okay, good. Before I go into distributed tracing, I'll first talk a little bit about microservices. You know, everyone talks about microservices just before this talk, right? It's a productive way of scaling a system and team. And at the beginning, when you heard of it, it sounds really great. And later, you start doing microservices. You realize it's too difficult to do things right in microservices. Let me show you something real from our system. So yeah, this is how our system used to look like when it launched back in 2012. How simple it is, right? So everyone must be familiar with this architecture. We only had a single monolithic Ruby on Rails app with one tiny database. So obviously, the only programming language we used was Ruby. Now, after 7 years, we've gone public, and we have offices in 4 countries, provide more than one app on platform. We now have more than 100 services, 20 databases, and it's polyglot. We use 5 different languages, like Ruby, Go, Python. For machine learning, people want it, Node, and Rust for whatever reasons. And the system looks like this. You can tell how complicated it is now. Now, challenge with a microservice architecture is understanding an entire system. Specifically, which microservices are involved in an end-user interaction. And you need that information. You need to know it when program happens. This is an example. On the left-hand side, you see our app. I picked this up. It looks really amazing. This is an app to manage your contacts by reading business cards. Oops, sorry. Yeah, so this is app that scans business cards, and when you scan, this app detects business cards and sends the image of the cards to the backend. Backend extracts text of the image, categorizes text into various fields like first name, last name, email, company name, address, etc. And gets information about the company and send it back to the user. So it does a lot. It does a lot of things underneath. On the right-hand side, you see a sequence chart that illustrates what exactly microservices and databases are involved, and in what sequence and from which microservices they are called. This chart is made by hand, by reading through source code of many different microservice repositories we had. And we made this particular one just because it was so important for new engineers in the team to understand how this particular endpoint works. But you can't do this. You can't do this for every API endpoint you have. You just can't make it, right? It's not practical at all. This is not an effective way of using your time. But you sometimes need this type of information when your users see some problem on the app. I'll explain you why. For instance, let's assume you have 7 microservices, A, B, C, D, E, F, and G. Plus, you have 2 databases for 2 features called X and Y. For feature X, an app makes an API call to service A, and service A makes a call to C and D, and C runs some query on the database and calls F, and D calls C. Now, let's say in your monitoring tool, you observe service G is unusually raising a lot of errors, something going wrong. And you look at any recent deploy has been made in service G, but it turned out there was no code change in last 1 week or month, so you have no clue why this error is happening at all. You are in trouble now. Suppose that you don't have a clear picture of dependency of those microservices. What you would have to do is randomly speculating and guessing which microservices could affect service G. And any changes made recently to each of those services in order to find out root cause of the problem. And even if you have a knowledge of dependencies, it's too difficult to tell its implication to users because it could be called from feature X or it could be called from feature Y. So when something goes wrong, you want to know exact user impact. You need to understand which features are affected. Maybe feature X is not that important, while feature Y is much, much more critical to users. So if there is any issue with feature Y, you want to fix it as soon as possible. So these problems, what distributed tracing addresses and solves. Distributed tracing is a technique that captures causal links of operation involved in a single request. This is a simplified view of a trace. You can tell what are the components involved. For a request, service A, C, F, D, G are involved, plus 1 database. And you can tell in what order they are called and how long each operation takes and which operation is failing or taking longer time than usual, if any. Just to explain some terminology of distributed tracing. Trace is a collection of operations performed within a single end-to-end request. A trace can contain multiple spans, and span represents a single operation within a trace. Could be HTTP request, could be SQL query executed, could be rendering something that takes longer time. And span can be nested to make a tree of spans, which represent a relationship of cause and result. So each span has a parent span, unless it's a root span. And span can be created by, for example, function call within a process or remote procedure call over HTTP request or gRPC, for example. And span contains information such as start time, end time, or along with other contextual information called annotation. Okay, let me show you here how distributed tracing really looks like. This one is from Datadog, which we use. Each color, we have 6 services here. Each color represents one service. There are 6 microservices involved in this trace. It shows you where it spends most of the time, right? And if you scroll down, yes, you'll see many requests are made, concurrently. If you click a span, hold on a sec, yeah. So if you click a span, particular span, you will see more information, contextual information, like I said. For example, you can set infrastructure information, which host and IP it used, or if it's API request, you can set path name or stack trace, or if it's a SQL query, you can put it SQL query itself on those span. Other information is like HTTP method, parameters, request size, response code, so on. You can put it here. Datadog also provides what it calls service map, which is effectively a dependency graph of microservices and database, which is similar to what I showed earlier. What's good about this is Datadog automatically creates just from live tracing data. So this really tells you the truth. It's dynamically generated from real data. If you click any of those, if you hold, you see dependency of each component or each microservice. And if you inspect, you see what are the upstream dependencies are like, and what the downstream dependencies are like. Also, Datadog also provides it takes time to load. More detailed information on a particular application or service. What are the endpoints of the service and how the latencies are distributed, right? So on. This is another example. This is from Stack Driver of Google Cloud. Pretty similar to Datadog. You can filter traces by, for example, latency which trace which has latency over 1,000 milliseconds, for example, and it visualizes distribution of the trace latency. You can click it and on the chart to see more detail. And like in Datadog, you can dig into more contextual information of each span if you click on that. Okay, so let's talk about Open Census now. Open Census is a set of vendor-neutral libraries to collect and export traces and metrics. I won't touch metrics part of the Open Census in this talk, but it does more than distributed tracing. It gives more observability of your entire system. Open Census is originally started at Google, people from Google, based on their internal library called Census. But it is now developed by a broad community of service developers and cloud vendors. Open Census provides libraries for major programming language. Java, I believe it's most mature implementation of Open Census. Go, Node, Python's also matured and implement full features of the spec. C++, C#, PHP, Ruby, Run/Elixir are a bit behind, but at least it supports tracing. And it itself doesn't provide analysis backend or UI. like one I showed you before. And it focuses on capturing those data, as it is a difficult part of it. And when I say vendor neutral, it means you can send traces or metrics to a backend of your choice. It has the concept of exporter, which you can configure to specify backends you want to send those data. It can be SaaS solution like Datadog or Stackdriver, or open source solution, Jaeger, Zipkin, Prometheus, if you have a capacity to run it on your own. You can even export to multiple backends at once. This is really handy because you can play around with it when you want to try a new backend, or a different team can use different tools if you want to provide it. It provides out-of-box integration for Rails, which I'll explain later in a minute. In Open Census, data model is defined using protocol buffers. So you can take a look at profile on GitHub to understand exact definition, what are the fields are, what are potential possible values are, so on and so on. And span, for example, has a number of fields listed here. It has a trace ID, which is a unique identifier of the trace and shared among the spans in the trace. Span ID, obviously, is a unique identifier of the span. And like I said, span has a parent span unless it's a root. So it has a field called parent span ID, and so on and so on. And it's worth mentioning here, you can create span both on the server side and client side when you make a remote procedure call or HTTP request. Kind is a field for that purpose. On the caller side, you set it client, and on the callee side, you set it server. Yep. And this illustrates rough architecture of Open Census. In each application, so we have 3 applications calling sequentially here. In each application, it has a collector and exporter module provided by Open Census library in any languages. And exporter sends span to the backend. Exporter module sends to the backend. So when a service makes a HTTP request, it propagates contextual information like trace ID or span ID on a HTTP header. And within the service process, it propagates contextual information, usually using the thread local variable, and create a new span from the context. And it's sent to a collector, and the collector sends it to exporters, exporters send it to the backend, multiple backend if any. In case of Ruby on Rails, it provides rack middleware to handle an inbound request. And it extracts current trace context from HTTP header and create a new span in the process. To handle an outbound request, it provides Faraday middleware. It sets HTTP header to propagate context and create a span. And by default, it also captures common events within Rails, like database query of active record, or rendering the view template of an action view. Now, in order to use Open Census, obviously you need to have Open Census gem and configure it when your process starts. You can specify where you want to insert the rack middleware. It can be beginning of the middleware chain, middleware stacks, or at the certain after the certain rack middleware class, or it can be at the end of the middleware stack. You can also specify which exporter to use. I will explain shortly after this. And the sampler determines whether a given trace should be reported or not. For example, you can always report all the traces in staging or development environment. while you can sample with a given probability, as in this example. In this example, 1% of the trace will be reported in a high traffic production environment. There are limits as well in the configuration. So in order to make sure tracing doesn't impact application process itself, not to impact much memory footprint, or network bandwidth of applications. It has a conceptual limits in various fields. For example, span has a limit in number of attributes. A trace has a limit in number of span it contains. And those limits are something you can configure as well. There is an exporter class for each backend. So you can make an instance of it and set it in config object. So in this example, first one is exporter class for Datadog. And second one is exporter class for Stackdriver. So you can instantiate it and set it on a configuration object. Each of those are provided by a different gem file, so you can just require whichever you need to. And you can even write your exporter if necessary, if you have an original backend, or if gem is not provided by community yet, you can actually write it. Datadog exporter was actually written by one of our team members for Ruby. And lastly, if you want to use multiple exporters, you can do that. You can wrap it in multi-exporters by passing exporters you want to use. For Rails, for Ruby on Rails, Open Census provides Rail tie. So actually, only thing you need to do is requiring Rail tie in the configs application.rb. And the top level configuration object we just see is exposed as in RailsConf. So config.opencensus. Blah, blah, blah is configs you can set it within application.rb. Now, let's take a look at what RAC middleware does. This is kind of pseudocode and a complete one, but it should be good enough for you to feel sense of it. As you know, every RAC middleware has a call method that takes env hash and returns an array, which is a response code, header, and body. And it executes app.call, where app is either RAC app or other RAC middleware in a stack. So you can inject anything before and after actual HTTP response is made for a given request. In this case, it extracts trace context from HTTP header in the first 2 lines of the call method, then creates a span with data from HTTP requests, like host name, path, method, user agent, and so on and so on. Then, when response is made, within this middleware, it taps result and populates more data onto the span from response. For example, response header and response size. And finally, it tells exporter to export all the spans created during the course of the response is made in a request. Okay. Like I mentioned, it instruments some common events inside Rails app, such as SQL executions, view template rendering, sending the file, email delivery, and so on. This is done using Rails API called Active Support Notifications, which allows you to subscribe certain events and set handler for events. So here in this case, It subscribes 5 types of events, and calls a method called handle underscore notification underscore event. And it gets called after the event happens. You subscribe here. Within the handler method we define here, it creates a span from current span context, which essentially takes a hash from current thread variable and set attributes from the notification event created from Rails and populate attributes from the payload of the event at the end. This is what Varade middleware does, very similar to rack middleware I just explained, but it is for an outbound request. So it basically wraps a HTTP request. So before making a call, it creates a span from current span context and populate attributes like URL to call, user agent, HTTP method, or anything from request headers. And after request is made, it populates span and closes it based on the response you got. And in case of error, it sets status to error state. Yep. So using Faraday middleware is really easy. When you initialize Faraday client or instance, you can just let it use the middleware. And I highly recommend you to do this in a private gem or so you don't need to repeat this in every Rails app you have. Yeah. So if you don't use Faraday and use something else for outbound requests, it's okay. You can instrument it using a custom span API provided in Open Census. You can use it for anything you want to instrument. Here's an example. This is some meaningless example, but it uses Open Census module, Open Census trace dot in underscore span method. And you pass in the name of the span when you call it, and you also pass the block to it. This is actual operation you want to do. Here it sweeps for up to 10 seconds. And in span method is basically creates span using the start span method and call block given and ensures span is closed. You can actually use start span and span method individually instead of in spans, but make sure you call end span method at the end. So lastly, you may heard of open tracing, which is a project from CNCF, Cloud Native Computing Foundation. And it is very similar to Open Census. In a sense, it provides support for different programming languages and different tracing backends, like Jaeger and Zipkin I mentioned. But luckily, you don't need to worry about which one to use now, because they just announced in March, they are going to merge. This is, you can Google it for more detailed information for this. Yeah. So this is the timeline of merge. It's already kind of started, and by I think November, they will kind of have merged libraries. But no worries about that. They kind of promise backward compatibility for time being, so you can start using Open Census now. Unfortunately, there doesn't seem to be a solid plan for Ruby implementation yet. Most likely because there's not much people is using open tracing or Open Census in Ruby, which means there's a good opportunity for everyone here to contribute in open census/open tracing world on the project. Okay, so let's wrap up. To summarize, you now know what's distributed tracing and how it helps you solve the problems in microservice architectures, and it gives you deep insight of your complicated distributed system. And you can start using it. You can start using distributed tracing today with open census. It's really, really easy, like I showed you. All right, that's it. Thank you very much, and please let me know your feedback. I appreciate your feedback. Thank you very much.